Good day, and welcome to my presentation on the assessment distribution of all 10 content areas based on cognitive levels as set by the CAPS curriculum for FET Mathematics. The 10 content areas are as follows. Number 1, functions. Number 2, number patterns, sequences and series. Number 3, finance, growth and decay. Number 4, algebra. Number 6, differential calculus, but only for the grade 12s. Number 6, probability. Number 7, Euclidean geometry and measurement. Number 8, analytical geometry. Number 9, trigonometry. And number 10, statistics. According to the CAPS curriculum, the cognitive level distribution is as follows. 20% for knowledge, 35% for routine procedures, 30% for complex procedures, and 15% for problem solving. And here we have a pie chart for a visual aid, where we can see 20% for knowledge, 35% for routine procedure, 30% for complex procedures, and 15% for problem solving. The types of formal assessment typically found in the FET Mathematics CAPS curriculum are test, examinations, projects, and investigations. During this presentation, we will not discuss any informal assessments, although this is an essential part of our daily teaching. This should be considered when planning a lesson to enable students to master the skills required at these levels. Next, we will discuss each content area in a bit more detail for FET Mathematics in general. Next, we will look at functions. Under knowledge level, we will see if the students can grasp the essential facts, definitions and concepts, like memorizing formulas and theorems, identifying key terms, and recalling mathematical properties. Under routine procedure, we will see if the students can apply established methods and algorithms, like solving straightforward equations, calculating derivatives or integrals, and using standard procedures for common problems. Under complex procedure level, we will see if the students can analyze and manipulate mathematical structures, like analyzing graphs and functions, finding inverse functions, and solving systems of equations. And under the problem-solving level, we will see if the students can apply mathematics in a real-world situation, like model scenarios, interpret data from graphs, and formulating and solving complex problems. Next, we will look at number patterns, sequences, and series. Under the knowledge level, we will see if students can recognize patterns in numbers and recall key concepts related to arithmetic and geometric sequences, like identifying repeating sequences and remembering formulas for the nth term and common differences or ratios. Under routine procedure, we will see if the students can apply established methods for a specific task, like finding the nth term, sum of a series. Under complex procedure levels, we will dive deeper into the sequence properties, where we will explore different sequences like investigating Fibonacci or other specialized sequences and understanding their growth patterns and unique properties, as well as problem solving with sequences where we will solve problems or challenges involving number patterns. Under a problem-solving level, we will see if the students can apply mathematical thinking to real-world scenarios, where they will need to infer patterns from data, like analyzing real-world data and identifying underlying patterns and predict future values. Next, we'll look at finance, growth, and decay. Under the knowledge level, we will see if the students understand the basic concept of interest. Do they understand how money grows over time? And can they differentiate between simple and compound interest? Under routine procedures, we will calculate simple interest, compound interest, and depreciation. Under complex procedures, we will analyze growth and decay in different options, like investigate how investments or debt change over extended periods, explore different options, and analyze trends to make informed decisions. Lastly, under the problem-solving level, we will create investment or loan repayment plans and work with real-world problems, where we can design strategies develop repayment schedules, optimize payments to minimize interest costs, and apply financial concepts to practical situations like saving plans or retirement plans. Next, we will discuss algebra. Under the knowledge level, we will see if students can recall essential algebraic concepts, understand algebraic identities and exponential properties, as well as grasp basic operations, like identifying algebraic identities, applying exponential rules, and performing basic calculations with algebraic expressions. Next, under routine procedures, we will see if the students can apply established methods for a specific algebraic task, like simplification and solving algebraic equations. Under complex procedures, we will determine if the students can master algebraic manipulations, like factorization and solving simultaneous equations. Lastly, for problem-solving level, we will see if the students can apply algebra in a real-world scenario, like modeling situations, solving problems related to finance, physics, or engineering, and interpreting solutions in context. Next, we will discuss differential calculus for grade 12s. Under the knowledge level, we will determine if students understand fundamental concepts related to slopes, rates of change, and derivatives, like grasping the idea of an instantaneous rate of change and recognizing derivatives as slopes and tangent lines. Under routine procedures, we will see if students can apply established methods for a specific task, like calculating derivatives, where we will find derivatives of a function with respect to its variable, as well as using rules like the power rule, product rule, and chain rule. Under complex procedures, we will determine if students can apply differentiation techniques, like optimizing problems and rate problems. And under problem-solving skills, we will see if the students can apply calculus to a practical situation, like motion analysis and growth and optimization. Next, we will discuss probability. Under the knowledge level, we will see if students understand the fundamental concept of probability and grasp the idea of change and likelihood, like defining probability as a ratio of favorable outcomes to the total outcome, as well as calculating probabilities for simple events. Under routine procedures, we will see if students can apply the established rules for specific probability problems, like using the probability rules to calculate probabilities. Under a complex procedure level, we will see if students can deal with more intrinsic scenarios, like using conditional probability to solve problems. And under a complex procedure problems, we will see if students can apply their knowledge in a real-world setting, like predicting outcomes in games of chance, assessing risk in decision-making, and modeling random processes. Next, we will discuss Euclidean geometry and measurement. Under the knowledge level, we will determine if students understand the units of measure and are familiar with properties of basic shapes, like converting units and identifying geometric properties. Under the routine procedure, we will see if students can apply established methods for specific geometric tasks, like solving geometric problems and providing reasoning. Under a complex procedure level, we will see if students can apply geometric theory, like providing geometric theorems as well as proving riders. Under the problem-solving level, we will see students can apply geometric theory to practical situations, like analyzing geometric relationships. Next, we will discuss trigonometry. Under knowledge level, we will determine if students understand the trigonometric ratios as well as calculating areas and volumes, like applying trigonometric functions to right angles and solving basic problems related to area and volume. Under routine level procedures, we will see if students can apply established trigonometric identities, like using the trigonometric identities to simplify expressions and solve equations, as well as using compound and double angle formulas. Under the complex procedure levels, we will see if students can apply trigonometric theory to provide trigonometric identities and prove the compound angles and double compound angle formulas. And under the problem-solving level, we will see if students can apply trigonometry to practical context, like analyzing forces, vibration, waves, or design structures using trigonometric principles. Next, we will discuss analytical geometry. Under the knowledge level, we will determine if students understand equations related to lines, circles, and conic sections, like recognizing linear and quadratic equations, and grasp the properties of geometric figures. Under routine procedures, we will see if students can apply established methods for a specific task, like graph plotting and finding intersections, as well as equation determination, where we will solve for the unknown coefficients in the equations. Under complex procedure levels, we will see if students can apply geometric transformations, like the transformation analysis, as well as distance and midpoint problems. And lastly, for the problem-solving level, we will see if students can apply analytical geometry to practical scenarios, like interpreting geometric properties, where we can analyze the relationship between shapes, as well as solve real-world problems related to distance, area, and transformations. And last, but certainly not least, statistics. Under the knowledge level, we will determine if students understand the concepts such as mean, median, mode, and standard deviation. Under routine procedure levels, we will see if students can apply methods to specific statistical tasks, like constructing histograms, measure of central tendency and dispersion, where we will calculate mean, median, standard deviation, and identifying outliers. Under complex procedure levels, we will dive deeper into statistical theory, where we will use hypothesis testing to conduct hypothesis tests and make inferences about populations and determine whether observed differences are statistically significant. And lastly, the problem-solving level. We'll see if students can apply statistical concepts to practical scenarios, like interpreting data and results, where we'll analyze findings from experiments or surveys and draw meaningful conclusions, as well as design experiments and surveys where we'll plan data collection and ensure that we have valid and reliable results. In conclusion, we explored the 10 content areas as well as the 4 levels of cognitive ability as identified by the CAPS curriculum for FET mathematics. Formal and informal assessments help us to gauge the students' cognitive abilities, whether it's in a classroom, a test, or real-world problems. Understanding assessment methods as well as the cognitive abilities can assist the students to have a more meaningful interaction. Some areas carry more weight due to their practical relevance or foundational importance. Understanding this balance helps prioritize our focus and teaching efforts. Thank you for joining me on this journey.